Okay, so take a look at this sheet you just gave. Hopefully, was just given to you. If you have this for homework, great. Some of you have it for Ed Puzzle with the sub as well. If it's for Clayton's class, it's for homework for sure. So now take a look at this first question. The figure is reflected over the y-axis. What is the length of A prime, B prime? Okay, so let's first go ahead and reflect this over the y-axis. If it's going to be there, it's going to flip over. Okay, so how far is A over here? That's 6. That's 5 spots away. No, it's 6 spots away over here. So we're going to go 6 spots away here, and that's going to be A prime. Guess what with B? B prime is going to be, let me try to autofocus this real quick. B prime is actually going to be right where B's at. When it's on the axis, it doesn't change. B prime is going to be right there. Well, how far is D off the axis? 1 spot. So D prime is going to be 1 spot there. And C is 5. You can tell it's on the 5. So that's going to be C prime. And then go ahead and connect them the best you can. And let's look at the question again. What is the length of A prime, B prime? A prime, B prime is right here. This length right here, right? And this question is actually being more in depth and asking, when you reflect something, does the image stay congruent? Is it the same size? Does it look the same? Is it basically, when I talk about it, I talk about identical twins. They look exactly the same. They are exactly the same, okay? So if A prime, B prime, we're wondering what the size of that is, what's the size of AB? We can look at it. It's going to be from 0 here all the way, well, it says -6, but we know that's going to be 6 units. So A prime, B prime is also going to be 6 units. Now let's take a second here and look at this point. This point here is going to be -6, +5. And now let's look at this A over here. This is going to be +6, +5. Now compare these two coordinates. A to A prime. What stayed the same? The y value. What changed? The x value. So if I was to write a rule, and we learned this, we did a whole quiz on this, when there's a y-axis reflection, the y stays the same. As you can see with the 5 and the 5, and the x actually is the one that changes. Okay? All right, let's go to number 2. Number 2 is a little bit of a trip. You're going to have to reflect over the x-axis and then reflect over the y-axis to form the image. All right, you can use your patty paper when you're doing this, and you're going to do the best you can with reflecting this. When I go ahead and, let me get some patty paper real quick. All right, so the figure was reflected over the x-axis and then reflected over the y-axis to form the image where x, y, and z represent the sides of the image. Okay, so the first thing it says is it was over the x-axis first. So what I like to do actually is, if you want to use the patty paper, you really don't have to on this one. But if you do, it may help you see what's happening a little bit. So this is 1 spot away. And again, this is R, S, P, Q. And if it gets reflected, this is going to be R. This is going to be 4 spots away, 4 spots away. This is going to be S. This is P way up here. So P is going to be way down here. Okay, and Q, Q. And really, again, the patty paper isn't necessary, but we're going to just show you what's happening with it. Then, if I go ahead and reflect this now over the other side, I want you to see what's going to happen. And basically, it's going to be a flip over. And I don't know if you realize this, with reflections, you can use the patty paper with that too. And as I do that, it's hard to see, but this is where Q went. This is where R went, S and P. And this is where X is, Y, W, and Z. So it's kind of funny how that just happened, okay? As I reflect that over here, and I used the patty paper the best I could so you could see through, kind of flipped it over that way. So you saw the flip happening. All right, now, when you see that, your questions are from PQ. PQ is right here. From PQ, what letter is it? It's Y. All right. From what's this going to be? QR, that's going to be X. From RS, that's W. And from Z or SP, that's Z. All right, best you can with the patty paper, okay? All right, guys, number 3. What series of transformations can be used to show that these triangles are congruent? Well, it looks like you're here to here. That's going to be a slide. When you compare these, don't go from here to here. That's not the same point. You got to go from the same points. That's very important. Do not forget that. And count 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6. Over 7, 6. So you could say it's a translation. Translates x plus 7, right? Y minus 6, or to the right 7 and down 6. That would be perfectly acceptable, okay? Very nice. All right, number 4. If we're dealing with 4, give a sequence of 2 transformations that will show the shape A is congruent to shape B. It says 2 transformations, so this one's kind of a trip. You got to think outside of the box on this one. If you want to use another part of the patty paper to see it, you can draw it again. It's smaller. But if you were to take this here, how are you going to get it to be up here? That's basically what they're saying, right? How did you get from A to B? So you could say, oh, I slid it up and slid it over. That's not going to work. But hey, when I notice I slid it up, doesn't that kind of look like interesting? When I slide this up, that's cool. That's a good spot. Doesn't it look like it's kind of in the same spot if I was to now flip it over? If I flip it over like a reflection, oh snap, it's right where it needs to be. So I could do it that way, which is actually going to work out well. What if I decided to flip it over on the bottom reflection and then move it up? I could do that as well. So either way, I'm going to say I'm going to move this up, translate it up. We'll say how many units? We'll say translate up. Let's see, where's this at 5? So this has to go from -2 up to the 5. So that's going to be 7 units up. And then what's this reflection over? 7 units up. Then reflect over Y axis. I hope you got that one. This is a little outside the box, but you're going to move it up here where it still looks good. And then you can see if it was perfectly drawn, it's just going to flip right over. So the 2 transformations would be a translation, then a reflection. Little intense, but you guys can handle that. That's not above your level. You are totally there at this point, okay? I'm not going to lower my expectations for you guys. Let's go. Flip it over. Number 5, the figure is translated 9 units down, then reflected over the y-axis. Draw the resulting image. You guys go for this. You can do this. We just basically did this in the last question. You're going 9 spots down. All right, 5, 4. This is going to go here. Then reflect it over the y-axis. So this one's kind of confusing. This is going to be 6 spots away. So it's over here, A prime. This is over here, B prime, but C is over here. It's 1 spot away this way, so we're going to put on this side. So that's what it kind of looks like, almost looks like a little butterfly wing or something like that. All right, let's go down here. Number 6, rotate around the origin. You got your patty paper, you can use it, or you can know the rule. It's -x, -y. But if you're going to go patty paper, make sure you go boom here, and then boom to here. All right. And that's where your other image is going to be. Okay? Cool. Let's move on. Number 7, the figure is dilated with a center of dilation at its origin and the scale factor of 2. Okay? What is the vertices of the original figure is at -1, 2. What are the coordinates of this vertex of this dilated figure? Okay, -1, 2. With a scale factor of 2, all it means is multiply by 2. Okay? So it's going to be -2. 2 times -1 is -2, right? And 2 times 2 is 4. And that's your new answer. All right? Super easy. Number 8. Are they similar or congruent? Okay, here's the deal. Do you see this one went from here to became very small, right? Are they twins? Or this is what I call it. I go big brother, little brother, or big brother or big sister, little sister. When you have a little brother and big brother, sometimes they look alike. They look similar. When you have a dilation, it is always similar, okay? Never congruent. They're not the same at all. And what is the actual congruence or with the scale factor? You can kind of look at it. It's over here. B is what? Over 6 up 3. And B prime turns into over 2 up 1. So what did it kind of go down by? This is going to be a tough one. It went down by almost like divided by. What did it get divided by? And if you look at it, it got divided by 3. But it's always with multiplying with fractions. So divided by 3 actually means a scale factor of 1/3. And that's a tough one. We haven't really gotten into that too much. All right, guys, you're on your own with this one. I want to see 21 squared plus b squared equals 35 squared. Go ahead and go for that one on your own, best you can. And then number 10, do the same thing. It's going to be 6 squared. Where's your L? All right, plus x squared equals 7.5 squared. All right, guys, do the best you can.